Good evening. In the last videos, we discussed very clearly about what are the various operations that we can able to perform on linked list and how to create a single linked list. And we discussed from some operations like creation of list, inserting a node at first location, inserting a node at last position. So all these things we discussed. Okay. So as a part of continuation for this, we need to see the few more functionalities in today's session. We will see first sorted insertion in ascending order. How we can able to insert the node at the beginning or any position based on the content, it will decide the position where we are trying to insert. Like, sir, what is that function name that we are going to do? Sorted insertion. Sorted insertion. That means when we are performing insert operation, we have to check what is the proper position of that particular element. Based on that, we have to insert. That technique is called as what? Sorted insertion. Let us see how we can able to do that. For this, I am defining one function called sorted insert. Sorted insert, where it will take a head and then data. Now listen carefully. First, I will run this. First I will explain the process. Then we will go with coding. Consider I have some elements are there, like first node content is a 10 and the second node is nothing but we have 20 and the third node what we have here is 30. Like this, I have three nodes are there. Last node is pointing to none. Like this we have. And this is nothing but the initial node which is pointing at a head. Now I want to insert the data called 25 to this head. So where it has to be inserted this 25? We know the 25 is going to be inserted here. Sir, there is no proper position. We have to fix the position by ourselves. Make sure that all the elements in the list should be in certain order. Then only we can able to insert. Sir, now after giving this head and the data, what we are going to do? Very simple. First, we will create a node. First, we will create a node with the given data. So what is the name of that node? Sir, here is the node that we created. The name of this node, I am taking it as a temp. The name of this node is nothing but a temp. Now, so we need to check if your head is equal to none. So if your head is equal to none means what? We don't have any elements in the linked list. The node which we are using, that will become the node. So just simply I am going to return temp. So if there is no linked list, the node which you created will become a new node, right? That's all. There is nothing more than that. Sir, I will better use elif. Elif, if the condition is not satisfied, elif, the data which you are trying to insert is less than head dot data. Sir, the data which you are trying to insert is 25. Is it less than head dot data? No. Suppose consider the data which I want to insert is 5. Is it less than head dot data? Yes. Then where this 5 have to be inserted? In this position, right? That's why I am checking the data which you are trying to insert. Is it is less than head dot data or greater than? If it is less than head dot data, your temp, that is newly created node, is there, right? Its next field will become head. Its next field will become head. And then what we are doing? We are going to return that temp. So what is the meaning of this particular statement? The data which you are trying to insert. Okay, the data which you are trying to insert is not available in the, if the data which you are trying to insert is less than head means what? So the position where we need to insert, that is nothing but the beginning of the list. So in such cases, the newly created node is there, right? Its next field will become head and we have to return that. Sir, if these two cases are not satisfied, then what is the meaning? So there is a proper place we have to identify. Sir, how we are going to identify? This is the very risky task, sir. Please listen carefully. I am taking the current node is equal to head node. I am taking the node this one. Okay, so this one I am going to consider it as this one I am going to consider it as which node? Current node. Now I will check the data and I will move the current node up to where? Up to here we will make. Okay. Now see what is the code for that. Sir, while current dot next is not equal to, okay, current dot next is not equal to none. At the same time, your current node is there, right? Its next node data is less than the data. Okay, means what? You can see here, sir, the current node dot next is the next node is existed. Yes. And the current node next data is nothing but a 20. Is it less than the data which you are trying to insert? Yes. That means what we are doing, sir, we are making current is equal to current dot next. So that what will happen? Now your current is pointing to this particular location. Now see what will happen. While current dot next is not equal to null, this is the current node. Its next field is not equal to null. And the current dot next, this is the current node, right? Its next field is 30. Is that data, is it less than 25? No, right? Condition is not satisfied. Then it will come out from the while loop. That means we came to the position exactly where we need to insert this 25. Sir, after this what we are going to do? We have to come out from the loop and your temp dot next is there, right? That will become current dot next. And your current dot next is there, right? It will become temp. And at last we have to return which node? At last we have to return head node. Now see what will happen. So temp dot next, this is the temp, right? Its next field will become current dot next. Current dot next is 30. That's why temp dot next will become 30. Then current dot next, this is the current. Its next field I am assigning to temp. Then return the head. Have you observed? Is the data is inserted in a proper position or not? Yes. This is nothing but the technique what we have, how we can able to insert the data. So I think you people got very clear clarity about this. So sorted insertion in ascending order. If you are doing sorted insertion in descending order, what we have to do? This symbol you have to replace with greater than. Beyond that, nothing. Can you please confirm everyone? Is this a skeleton? Is it clear for you people?
Yes, sir. Yes, sir.
Right.
Clear,
Now,
sir.
yeah, now we will run this code. Okay, because we have to check whether it is going to work properly or not. Now, assume I am taking head is equal to none. Then I am going to print a list of head. As you can see, there is no element in the list. It is going to print. So print list is not defined. Ayo. So the problem with this, I think again we have to run these codes one by one, because to activate
Yes,
the
sir.
scope, where is the print list function? Can I run like this? Any data will be lost? Can you please confirm anyone? Because I don't know more about this Jupyter. Are you sure you want to restart the current kernel and re-execute whole notebook? All variables outputs will be lost. Okay.
There is option to run all the cells.
Hmm.
There is option to run all the cells.
This one?
No, sir, not this.
Where it is there? Cell. Run cells, control enter, run all. Can I write like this? Yeah, now you can see. So now you can see here. Yeah, thank you, sir. You can see when you are printing the list, we are getting the list is empty because we don't have any elements. Now what I am going to do is, so head is equal to, I am trying to call, so insert, what is a function? Sorted insert we have taken. So sorted insert of, I will take 30. Okay. Again, head is equal to, I am taking sorted insert of, I am taking the function called 40. So head is equal to, I am taking sorted insert of, I am taking 50 or 60. Now you can see where these values are going to be stored. Let us run this code. Sir, something is problem here. Sorted insert. Yesterday also we faced the same issue. Additionally, we have to pass the value of head also. Then only it is going to insert. Have you observed? I inserted 30, 40, 60 because it is there in the order. That's why we don't have any issue. Now what I am going to do is I will insert a sorted insert of head comma. I am trying to insert a 25. So where it is going to be inserted? If you want, you can see the diagram. So we have already 30 is there. So 40 is there. 60 is there. Next is none. We are trying to insert a 25. So in the logic, you can see, is your head is equal to none? No. The data which you are inserting is 25. Is it less than head dot data? Yes. Then what will happen? So this next field will become what? 30 and return that. So definitely this data has to be inserted in which location? This data is going to be inserted. So in the beginning of the list, sir, if you want, you can see 25 is inserted at beginning of the list. Okay. So now I want to insert. Now I want to insert. So something like 35. Where it is going to be inserted? In between 30 and 40, it is going to be inserted. You can see here. So I want to insert a 45 where it is going to be inserted in between 40 and then 60. Now I want to insert a 50 where it is going to be inserted in between 45 and then 60. Now I want to insert a 55 where it is going to be inserted in between 50 and 60. So sorted insert function is working perfectly. Now I want to implement these for sorted insertion in descending order. Sir, just try to call by using DESC, descending order. So what we have to do? The total task is the same, right? If data is greater than head node, so then here also we have to replace less than with greater than. Nothing more than this. Now I'm going to copy this entire cell. Okay. And we are going to paste here. Now you can see. So in the place of sorted ascending, I'm going to take sorted descending function, and you can imagine how the data is going to be stored. In the descending order, it will store. You can see 60, 55, 50, 45, 40, so 35, 30, 25. Like this, the data is going to be inserted in which order? Descending order. I think, sir, you people got very clear clarity about. Okay, so I think you people got very clear clarity about how it is going to work. So any doubt on this sorted insertion in ascending order and descending order? Please confirm everyone.
No, sir.
Hello,
Is the
sir.
concept is clear? Yes.
Sir, in sorted insertion in descending order in the elif loop, we will return temp or head.
Return temp only, because in the first case and the second case, so what we are doing, we are going to create the new node as a first node, right? In the first
Yes, sir.
case, if head is equal to none, the node which you created will become the new node. That is the head. That's why I am assigning temp to head. Okay. In the second case, so temp dot next will become head. That means the first node will become temp. Its next node is head. Again, I am not reassigning. Simply, I am going to return temp. So once if you return that temp, it will be assigned to head. Automatically, what will happen? the data is going to be, I mean, the next data that is a head pointer is going to remove. Now my head is pointing to the beginning. Sir, then why you are not returning temp here means we are not using the temp because temp will be there somewhere in the middle. So whatever modifications that we are doing, at last we are going to return the head. Got the difference?
Yes, sir. Yes.
Right. So please confirm everyone, is the sorted insertion. Is it clear for you people, guys? So sorted insertion in ascending order and descending order. I think middle element in the list also yesterday we completed.
Yes, sir. Completed.
Right. So next we will see about the delete operation because that is the very important operation that we have to do. Okay. Now, so consider this is my data which I have. I want to write a program, write a function to delete at first. Okay. So where we are going to send a head pointer. See, suppose consider I have a data like this. There are two cases are there. So in the first case, I have only one node is there. So that node is nothing but which node? Head node. In the second case, I have multiple nodes are there. So this is nothing but I am taking it as a head node. And the next node for this is nothing but like this we have 20. Okay. So like this, I have some nodes are there. Now I want to delete from the beginning. Sir, delete from the beginning is very simple approach, right? What we have to do? Delete at first. We are going to check is your head is equal to none. If your head is equal to none, then we are going to return none because there is no linked list, right? So otherwise what we are going to do? Else we are going to return. So head dot next. That's all. Only two operations. Sir, in the first case, what will happen? We are going to return head dot next. What is a head dot next? None will be written. If you have only one node is there, that node we are deleting and we are returning. So when we have multiple nodes are there, then head next will become this one, right? So now this we are going to return. This we are going to return. If you return this, that we are copying to the head, right? So now onwards 20 will become head. That is the operation. If you want, just let us run this code and cross check whether the data is properly deleting or not. So sorted, I think better we can go for sorted insertion in ascending order. Better I will take this particular code. Now consider I am running. This is the output what I have. So I am calling head is equal to, okay, delete first, delete at first. What is the method name that we have taken? So delete first. We are passing any other nodes that we are passing, head pointer we are passing. So then what will happen? After this, we are printing the list with head. Now just run this code. So delete first is not defined. 1 second. Delete at first we have taken. Now let us run this code. Sir, are you seeing the first element got deleted or not? Yes. This is the way how delete first is going to work. Sir, very simple operation. In the case of delete first, simply we can able to return head dot next. If the list is empty, we are going to return none. If list is not empty, we are going to return the next node to that particular head. I think you people got a clarity about this. Can you please confirm, friends, is the concept is clear? Delete first function.
Yes, sir.
Right. Right. So the next one, what we have. So I want to talk about the delete last. So DEF. So delete at last I am taking. Sir, how to delete the element at a last location? Just I am giving head reference. So what we have to do? If your head is equal to none, that means there is no more elements. Simply I am going to return none. Otherwise, what we are doing? Sir, head dot next is equal to none. If there is no more elements except head, then simply the node which we are going to delete is nothing but the same node. So there are two cases are there. Let me draw those two cases. Please listen carefully, friends. So what is the first case that I have here is, this is the node what I have, that is only 10, and head is nothing but the reference variable pointing to this. Otherwise, consider I have some nodes are there, like 10 is nothing but this node, and 20 is nothing but another node what we have, and 30 is nothing but the another node what we have. Okay, and 40 is nothing but the another node what we have. Like this we have. Sir, what will happen? This node will become which node? Head node. There are two cases. What is the first case? If head is equal to none, that means what? There is no more elements in the list. In such cases, simply we are going to return. So this is the case. I have only one node is there. If you call delete last, this node has to be deleted, right? So if you delete this node, your list will become empty or not? Yes, that's why if head dot next is equal to none, that means if there is no next element to the head, simply I am going to return none. Sir, these two cases are failed. That means what? I have a big list is there. Then what we have to do? So take current node or temporary node is equal to head. Take the current node or temporary node is equal to head. Assume this node will become my current node. What we have to do? You need to move the current to till 40. Okay, how you are going to move? While so temp dot next is not equal to none, till that we have to move. How to move? Temp is equal to temp dot next. Temp is equal to temp dot next. Sir, please cross check how it is going to work. This is my temp. Oh, not a temp, current, right? Okay, let it be, change this to temp. Sir, this is my temp. Is this a temp next field? Next field is not equal to null. Yes, then this will become your temp. Is my temp next field? Next field is not equal to none. Yes, then move temp here. Then temporary node next field is not equal to none. No, it is equal to none. So stop the process. Now we got right. So before 40 we stopped. So just we have to break this link. How you can break, sir? After coming out from this while loop, can I take temp dot next is equal to none? So what will happen? My temp is nothing but 30. Its next field is nothing but none. Automatically this link is going to be break. Sir, after this, what we have to do? So we are doing the modifications on head, right? So we have to return that head. That's all. Now let us take this, and instead of delete at first, let us take delete at last. Run the code. Sir, is the last element what we have? Sir, what is the last element that we have here? I think you can see it is nothing but 60. Sir, is that 60 got deleted or not? Yes. So this is the way how we can able to delete from the beginning and how we can able to delete from the ending. Sir, please confirm delete at first and delete at last. Is these two concepts are clear for you people, guys? Please respond.
Yes,
Yes,
sir.
sir.
Yeah, sir, I request everyone to please participate actively, because with this much strain I am taking to explain for you people very clearly. If you people are not responding, then that is not correct. Please concentrate.
No, sir, clear, sir.
Right. What is the next approach? Very, very difficult approach. That is, we have to delete from the specific location. Sir, how we can run the code? Sir, if you think the logic, it is very simple, but writing the code is nothing but somewhat complex. So delete at location, we are going to give the location. Position means 1 2 3, location means 0 onwards. Okay, suppose consider I have a node is there. Okay, I have a node is there like this. So consider I have some nodes are there with some content like this. like this I have. Last node is pointing to none. So this is nothing but my head node. So data is 10 and here data is 20 and here data is 30 and here data is 40. Sir, what I am going to do is I will give the location is equal to. I want to delete the element which is present at 0, 1, 2, the element which is present at second location. So what we have to do? We need to take one special pointer. That pointer has to move up to 20, right? So otherwise, let us take one more node here like 50, none, and this is pointing here. Assume 0, 1, 2, 3. I want to delete the element present at third location. I want to delete the element present at third location. Let us see how we are going to do. Very simple. Delete at location I called, and I am going to assign your temp will become head. So where my temp is initially pointing, so here my temp is pointing initially. Okay. Now I'm going to check. Array boss, is your temp is equal to none? If your temp is equal to none, then what is the meaning? Sir, we don't have any elements there. Then simply we can able to return head. That means none only. Or you can return none also, no problem. If there is no elements. Suppose if your location is equal to 0. So we are trying to delete an element from the location 0. That means what? It is the same like insert first, right? Then I am taking head is, sorry, delete first, right? Head is equal to head dot next, and we are returning the head. Sir, these two conditions are failed. So try to take one special variable called I is equal to 0 and check whether your I is less than location minus 1 and check the condition like your temporary node is not equal to none. So we have to do two statements like you have to move temp and increment the value of I. Why? Because in which location you need to delete third 0, 1, 2, 3. This element we have to delete. I need this temporary variable up to this, right? Then only we can able to delete. That's why. Sir, initially my I is equal to 0. Is 0 is less than location minus 1. 3 minus 1. Yes, condition 2. And is temp is not equal to none? Yes. Then two operations. One is make this as your temporary node. Make this as your temporary node and increment I by 1 unit. Now 1 less than 2. Is the condition is true? Yes. Then what will happen? Temp is also not equal to none. Then we are taking temp is equal to temp tends to next. That means your temp is coming here. Then your I value is incremented. Sir, is I less than location? Condition is not satisfied. It will come out from the loop. That means we are in this position. We have to skip the node called 40. Sir, it is a very simple instruction, sir. So we are checking one condition. What is that condition is? If temp dot next is not equal to none. If temp dot next is not equal to none, then what we are going to do? So temp dot next is equal to none I am taking. Sir, this is the temp. Is a temp dot next is not equal to none? Yes, it is not equal to none. So if it is, one second, something is wrong here. If temp dot next is equal to none, I think so we have to take. If temp dot next is equal to none, then no need to write this one, right? Okay, I will remove this and I will write one more statement. Can you please cross check? Sir, can I take temp dot next is equal to, so temp dot next, can I take like this? Yes. And then I am going to return head. See what will happen. Sir, temp dot next. This is the temp. Its next field is 40. Its next field is 50. So your temp dot next I am assigning to 50. If you break this link, automatically this node is going to be deleted. Suppose consider, okay, so I think this is going to work. First, let me check. Let us consider this particular code. Delete at location. In which location I want to delete? I want to delete at 0th location. Ashish, can you please be on mute?
Sure, sir.
Please be on mute for a few minutes. So in 0th location, I am trying to delete. Let us see. In 0th location, we have 25 that got removed. I want to delete from the first location. Is it going to delete? Yes, 30 got deleted. I want to delete from second location. 35 got deleted. I want to delete from third location. 0, 1, 2, 3. 40 has to be deleted. Yes. I want to delete from fourth location. 45 got deleted. I want to delete from fifth location. So 50 got deleted. I want to delete from sixth location. So 55 got deleted. I want to delete from seventh location. So now you can see 60 got deleted. Have you observed? Like this, it is going to delete all the elements. This is nothing but how you can able to do, sir. Sir, very simple logic here. You need to find out the location and you have to move up to that location. Once if you reach to that location, then immediately you are going to stop. Beyond that, nothing. Please confirm everyone, is the delete at location functionality, is it clear for you people?
Yes, sir.
Yes, please confirm everyone, is it clear up to this whatever I covered?
Yes, sir. Clear.
Right.
So like if we delete the last element, so temp
If
dot
we
next
delete last element, then what will happen? 1 second, 1 second. Let me explore that area also. 1 second.
then temp dot next will point to
What
null.
will be your location? In this case, what will be your location if you want to delete the last element? 0, 1, 2, 3, 4, right?
Right.
So initially temp is pointing here. So 0 is less than 4 minus 1. That is 3. Condition true. Temp will move here. So 1 less than 3. And 2 less than 3. Your temp will move here. So 3 less than 3. Condition is going to be stopped. I think it will move up to this, right? Up to which location it will move? I think up to here we will get a temp. Is it correct? So I is equal to 0. 0 less than location minus 1, 4 minus 1, 3. And your temp is not equal to none. Then so temp is going to move here and I will become 1. This condition is also true. Then temp will move here. So then your I will become 2. 2 less than 3 and temp is not equal to none. So this temp will move here. 3 less than 3. The condition is going to be stopped. Now see what we are doing. Temp dot next. Temp dot next is equal to. So temp dot right side. Temp dot next. Dot next. What is a temp dot next is 50. 50 next field is none. Now what I am doing? Temp dot next will become none. That means this node will be deleted. Clear, sir?
Okay, sir. Clear.
Right. So this is the way how we are going to perform delete operation. So delete at various positions are clear. Now I want to delete an element or I want to delete the elements. Let us see how we are going to do. If I want to perform delete operation, same something like this, but we don't have any location. In previous case, we have location. That's why it will become very easy. So head comma data I am taking. Now consider if your head is equal to none. As usual, we are going to return head. That means we will return none only. So if head dot data is equal to the data which you want to delete, then your head will become what? Head dot next, and I am going to return that head. I think you are clear with these two logics. Suppose consider I have some list is there where, so this is the first node, like we have 10, and this is the next node what we have like 20, and this is the next node what we have like 30, and this is the next node what we have like 40, and consider this node is nothing but 50. Like this we have. So head is always referencing to the beginning. Suppose consider I want to delete the element called 10. This condition will satisfy because head dot data is 10. Your data is also 10. Then head is equal to head dot next, and we will return 20 as the head. It is a very simple operation, but I don't want that. I want to delete the element called, consider I want to delete 30. Sir, what we have to do? You need to take a temporary variable. Okay. Like I am taking, very, very important. Please listen. Temp is equal to head. So I am taking this as a temporary variable. Please listen carefully, friends. There is some small twist is there. Temp is equal to head. Sir, while your temp dot temp is not equal to none. Sir, is my temp is not equal to none? Yes. Then we will check some condition. If a temp dot data is equal to the data which you are looking for the deletion, then I will break. Check here, is the temp dot data is a 10. You want to delete 30. Both are same? No. Then what we are doing? I am taking previous is equal to temp, and your temp will become temp dot next. Sir, very simple operation. I am giving this node reference to previous. Temp is equal to previous. Now this temp is moving to here. Since it is a while loop, is your temp is not equal to none? Yes. And the data which is available in the temp is the data that you want to delete? No. Then what will happen? Okay, then what will happen? Sir, simply we are going to make this one as a previous node, and then we are going to move temp to the next one. Now observe carefully. Temp is not equal to none. Is the temp dot data is equal to that data you want to delete? Yes. Break means what? We came out from the while loop. So now I think you got clarity. We have two pointers are there. One is pointing at 20, another one is pointing at 30. Sir, how you can able to break the link? So 20 next field should be, so temporary next field, right? Because we are not locating based on location. That's why we have taken 2 pointers. Sir, now you have to check, is a temp is not equal to none, because if it is available in the last field, then it will become difficult. If it is not there in the last field, then your previous dot next will become your temp dot next and return your head. That's all. Sir, now what happens? Your previous dot next will become temp dot next. Temp dot next is 40. That's all. This is the link which we established. Okay. I think you people got a very clear clarity about this. Sir, now we need to check how it is going to work. Okay, we need to check how it is going to work, because it is a very difficult task, right? Let me cross check what will happen. Let us run this code. Oh, first we have to give the data invalid syntax of where here double equal to we have to take. So now let us give this particular data only. Yes, I want to delete the node. Okay, so delete element head comma, which element I want to delete? Let it be 35. Okay, let us delete 35. Now let us run. Sir, 25, 30, 35 is the 35 is removed. Sir, what will happen if you have multiple 35s? What will happen? Have a look once. Sir, 1 second. 25, 30 is there, 30 is there. So 35. Okay. What will happen? Is it removed? Can you please cross check? Yes, first 35 got removed. Remaining 35s it is keeping as it is. Remaining 35s it is keeping as it is. You can, if you want, you can see. So first 30, 30, 35. Okay, not this one, this 35. This 35 and 40. So first 35 only it is removed, not all the elements. Sir, I want to delete all the elements. I will take the same function name. Let us write delete elements. Sir, what we can able to do? Instead of break, okay, instead of break, we have to continue this process. We have to check for another condition. So what we can do here? Anyone, can you please guide what operation we can? Sir, before that, can you please confirm, everyone, is the deletion of an element, is it clear for you people?
Yes, sir.
Yeah, then we will go
Yes.
for the next one. Please confirm everyone is the deleting element. Is it clear for you people? Please confirm everyone.
Yes.
So let us see how we can able to perform deletion of if any that element is repeated. Okay, if that element is repeated, then how you can able to delete. Let us think and see the solution for this. If it is returning something, then we can able to delete directly, but it is not returning. If temp dot
Sir, at the place of break inside while loop,
hmm,
we can just make a connection between previous and the value which is the node which is after temp, and we can again trace using while loop only.
you are telling this line we can keep there, right?
Yes, sir. Just break the.
1 second. After this, I will use a break and just to check, is it working for this case? If it is working for this case, then we can remove break. Now let us run. Is it removing 35? 235s are there, 235s. Now if I remove break, what will happen? This process is going to keep on running, right? Now let us cross check. Will it going to delete all 35s? No, it is not deleting 35s. Only 135 it is removing. 1 second, I will try to work with some other logic. So here, if a head is equal to none, then we can return none. If your head dot data is equal to data, we are going to return head dot next. Here I am taking temp is equal to head I am taking, while your temp dot next is not equal to none. Okay, and I am checking is your temp one temp dot next dot data is equal to data. If it is the case, then so temp dot next will become, can I take a temp dot next? Yes. So then I'm going to take another temporary variable. Like temp1 or temp pp, like this I'm taking, which is going to point temp dot next, and we are checking if temp pp is not equal to or equal to none, means then so we can delete that node directly. So if temp dot next dot data is equal to data, temp dot next will become temp dot next dot next. I think this is sufficient. So after this, Can I write a return statement? And at last temp is equal to temp dot next. Can I use like this? And at last I'm going to return head. So instead of return, better to go for okay, return head. Let us dry run this. So consider I want to delete the data called 20, sir. Please listen carefully. I want to delete the data called 20. It is not present in the head. Temp will become head. Temp dot next is not equal to none. Temp dot next data is equal to the data. Yes, then temp dot next will become temp dot next dot next. Temp dot next is 20, its next is 30. Now like this we connected. Then we are going to return. Okay, so it is going to return. First, let me run this code. So here is the 35 is removed, first 35. Yes. Now I'm going to remove this particular return keyword. Then what will happen? Now see, this instruction got executed. Then it will come out from this if condition. Your temp will become temp dot next. That means temp will become 30. Is a temp dot next is not equal to none? Yes. Then temp dot next dot data is equal to 20. Yes. Then again temp dot next will become temp dot next. Yes, I think it should work. Let me cross check. So now I'm going to run this code. Sir, is all 35s are deleting? No, only one occurrence is removing.
Can we use recursion?
Sir, that
No, we
your
can't use recursion.
delete elements is
That is
Maybe
the
we
problem.
can just
Sir, we are changing the method name, right? We are not using that method name. That is the problem. Now cross check. So how many 35s deleted? Only two 35s deleted, right?
so maybe you can just put it like if it is greater than 35, then delete the previous element. Something.
No, this is okay, but it is sorted insertion. That's why your logic is going to work. But if the data is not in sorted, then
Okay, yeah, makes sense.
this list will work, sir, for unsorted list. Since it is in the sorted order, that is the problem. Let us see. We will check for insert. So insert at last. Insert at last. Assume the data which I am going to take here is so 111, 222, so 333, 444, so 555, 666, so 777, 888, like this we have. Assume I want to delete for 333. Definitely one occurrence will be there, it will be removed. Suppose consider here also I have 333. Then definitely it is going to remove both because the positions are completely different. Okay. But if it is having in a continuation manner, then we can't give guarantee. Here we are going to get that. How you can detect? I think here we are skipping one node. You can see. Can I take a temp is equal to head if temp is not equal to none? Let me run this. So here temp is this one. It is not equal to none. Let me delete the previous content. So temp I am taking here. Assume I want to delete 20. Here also 20 is there. Here it is 30. So temp, it is not equal to none. And temp dot next data is equal to data. Yes, then what will happen? Your temp dot next will become temp dot next. Okay. Then your temp will become temp dot next. Here we are getting. So while temp is not equal to none, this is not equal to none. So what is happening here? So we are checking temp dot next data. That is the problem. Next node data we are checking. Can we check the current node data? Now run from the beginning. So initially temp is pointing here. So it is not equal to none. And the temp dot data is equal to data? No. So then temp will become temp dot next. So temp dot data is equal to data. Yes. Then temp dot next will become, oh, previous pointer is going to loss. Okay, sir, we will see that later, but I think now you got a clarity how it is going to work. For unsorted list, it is coming. For the sorted list, we have to think and we need to write. So can you please confirm, is the concept is clear up to this? Please confirm everyone.
Yes, sir.
Right. So I think how to delete the element, deleting the elements, both are clear for you people. Now search operations I want to implement. So we will see multiple search methods. Right. So consider this is nothing but the data what I have. I want to implement which operation? Search operation. Search one I am taking, where it is going to take a head and then data. So what is your requirement is nothing but we have to search for this particular data.
Sir,
Where it
like,
is.
sorry to interrupt, like in the previous question, we can make one more pointer, like, actually the problem is coming here, like our, the pointer is getting lost. If
Yeah,
we
yeah,
are,
that is. If you
so we
maintain
can,
one more pointer for holding previous node, then it will be
yes, sir.
corrected. Yeah, we can do that, sir, because I don't have code for that. You can try by your own. If you
Okay,
get
sir.
time, tomorrow I will explain that process. Okay.
Yes, sir.
Right. So let us go for search operation. So the searching is very simple, right? What we are going to do in the searching, suppose if I have element called 10, so 20 and then 30 and then 40, like this I have elements. So link is there. You have to take the temporary variable and you need to check is the data is matched or not. If the data is matched, you can return true. If the data is not matched, you will go for the next node. It is a very simple process. Sir, what we are going to do here, I will take a temporary node which is pointing to the head and I will check. So while your temporary node is not equal to none, so what we are doing, so we will check a condition. If your temp dot data is equal to the data which you are looking, then we are going to return the message saying true. So otherwise what we are doing, your temp will become temp dot next. Sir, I traveled throughout the loop, I mean throughout the list, but nothing is found. Then we can return false. Very simple algorithm. But I want to run this. Let us take these elements, 111, 222, something like this we have, 777, something like this we have. Now I want to run this code. So what is the output that I'm going to take? Print of, I will call the function called search1 by passing head and then I am searching for 444. And the same function I am going to call for 999. You can see 444 is existed, but 999 is not existed. First one we are going to return true. Second one we are going to return false. Sir, now same search operation I want to implement in such a way that I need to return the location. So if you want to return location, what we have to do? Declare a special variable called I is equal to 0. And whenever the temp data data is found, then can you please return the value of I? So otherwise what we are going to do? Temp is equal to temp dot next and your I value will become I plus 1. At last you can able to, that's all I think so, right? We are not required to return anything. If the element is not available, we can return -1. Now see what will happen. The same operation I am going to call by passing search2 function. So where that particular 444 is available, 0, 1, 2, 3. In third location it is available. And if you are searching for 999, since it is not available, it is going to return -1. And let us check whether it is available in the beginning location, value is coming or not. Yes. So these are nothing but two ways of search functions. One is going to return true or false, like it is going to check whether the element is available or not. But the second one is going to check the position where it is available. Okay, so I think you people got a clarity about these two. Any doubts?
No, sir.
Is the concept is clear? Please confirm.
Yes, sir.
Yes, sir.
Yes, sir.
Right. So now we can go for, sir, one more sorting technique. I mean, one more search operation. So what is that one more search operation? Think a bit logically. We have to use recursive process. Okay, I want to take recursion process. So to check that particular element is available or not. So if that element is available, as usual, we have to return true. If the element is not available, we have to return false. So by using that true or false, we need to, I mean, true or false, we have to return. But what we need to do, we have to write a recursive code for this. Okay, we have to write a recursive code for this. Let us see how we can able to write recursive code to implement this particular algorithm. Let us see how we are going to work with that. So we need to take a Boolean function. Okay, we are going to take a Boolean function and we will implement. 1 second, sir, please wait. Yeah, let me take a recursive function like def. Better to give the name as a search tree. I will pass head as usual. I am passing data. What we have to do, if your head is equal to none, because base case we are going to satisfy. If your head is equal to none, then what is the meaning? The data is not available. Simply I am going to return false. Otherwise, if your temp dot data, better in the place of head, try to take a temp. If your temp is equal to none, then return false. If temp dot data is equal to, okay, if temp dot data is equal to the data what you have given, then can you please return true? Otherwise, what we are going to do, we will call search tree function by passing temp dot next comma the data. Sir, it is a recursive process, right? Because, so you will see how it is going to work. I will explain. So let us run this code and cross check whether it is working or not. Sir, what output we are expecting for this? We are searching by using search tree function. We are expecting true or false. Let us run. As you can see, 444 and 111 is available. 999 is not available. How it is working? Sir, first we are going to give temp. Temp means assume this is nothing but the temp. Of course, it is the head. I am giving this as a temp. Is a temp is equal to none? No. The data which I am searching is 30. Sir, is a temp is equal to none? No. Then temp dot data is equal to data? No. Then search tree. I am going to call search tree function by passing temp dot next. Now this entire list I am going to pass. Sir, take this one as a temp. Is a temp is equal to none? No. So is a temp dot data is equal to your data? No. Then again temp dot next. Again search operation. Like that it is going to work. This is nothing but the recursive search what we have. Sir, in the recursion, I want to positions. Can I do? Yes, we can implement that. Let us take a search for operation I am taking. Sir, in addition to this data, I will take integer index also. Please look a bit very carefully. If temp is equal to none, I will return -1. If temp is equal to none, I will return -1. If the temp dot data is equal to data, I will return index +1. Please listen carefully. Index +1. Otherwise, I will call this function by passing temp dot next comma data and index +1. Sir, this terminology is okay. 1 second, somewhere data type I mentioned. Sir, this data is okay, but when you are calling, sir, search for function is there. What index value that you are going to pass? I am assuming the data is not available initially. I will pass -1. Please think a bit very carefully how it is going to work. Assume I am searching for the data called 30 and index value that I have given is -1. Now see how it is going to work. Initially, we are giving this particular node reference. That is a head node reference. Is your temp is equal to none? No. Is a temp dot data is your data? No. Then I am calling temp dot next by passing this and the data. I am not giving index value as a -1. I am giving index value as index +1. So what is the previous index? -1. -1 plus 1 will become 0. Now this will become temp. Is temp is equal to none? No. Is temp dot data is equal to your data? No. Then what will happen? We are calling search for function by passing temp dot next and index plus 1. Sir, now check. Is your temp is equal to none? No. Is your temp dot data is equal to your data? Yes. Then return index plus 1. In this location, what is the index value? 1. 1 plus 1 means 2. 0, 1, 2. Is it clear? I started from the beginning. That's why plus 1 if you take, we are going to return the index. Let us check, sir, whether it is returning or not. Sir, have you observed? In third location, 444 is available. 0, 1, 2, 3. So 999 is not there, -1. So 111 is there at 0th location, 0. This is the way how we can work with which operation, sir? Search operation. Can you please confirm? Is these concepts are clear up to this whatever I covered?
Sir, can you write the comments like yesterday? Mention.
Yeah, I have written, sir. I have not written, I think so. I will write, sir. Don't worry. After completion of the
thank
session, I
you.
will add.
Yes.
So clear up to this?
Yes, sir.
So this is nothing but how we can able to work with this. Okay, right. So practice up to this whatever I have covered. So remaining things we will continue in the next class. Sir, tomorrow, day after tomorrow and Sunday also, I am not taking any class. Next class will be on Monday. Monday, we are going to see the few more operations like how to remove the duplicate elements in the sorted linked list. That is the problem I think we have faced. For that, we are going to get some solution, and how to create a copy of list and reversing the linked list and comparing the linked list, nth node from the beginning and ending, and palindrome. These things I will cover for single linked list. And
Sir,
sir,
please cover one more question. Like if we have two linked lists, we have to add them. Like this question I faced in a online assessment.
sir, it is easy only, right? How you can able to add those two
Like
linked
if
list?
one number is 7 digit and another number is like 3 digit. So in that case,
No. You are asking concatenation of two linked lists.
no, sir. Like if we have 700 and another number is like 80, so output should be 780.
So
Adding basically we
first,
need to tackle the
yeah.
carry also in this case.
No. I'm not getting your question. If your linked list is a 10, 20, 30. Okay. Next list
Yes,
is?
sir. 5,
Okay.
3,
Okay.
8.
Okay. What is your expected output?
Like, sir, 15, 23, 38.
It is easy only, right? We have two linked list objects are there. You are going to traverse both linked list. In the first linked list, whatever data is there, I mean temporary data, and in the second list temporary data, you are adding. Maybe if you want a new linked list, we are creating that.
Like, sir, it was like first 10, 20, 30, 5, 38. Like we have to add, then the print the final output.
Sir, this is the question, right?
Sir, I exactly don't like remember the question, but I think firstly like 10, 20, 30.
The concept is the same, right? You have to
Okay.
add the element which is present in the linked list with the element present in another linked list. That is your question.
Yes, sir.
So that is very simple. See, we have two linked list objects are there. What we have
Okay.
to do? So you need to traverse every element from the first linked list, and you need to traverse every element from the second linked list. So
Okay.
first element in the first list, first element in the second list, you are doing addition. Maybe that addition they have asked in the different scenarios. If it is different scenario, that mathematical logic you have to apply. That is not problem related to the linked list.
Okay, sir.
Are
I
you getting?
remember a bit like there is also some carry when I have after the test I have seen the solution. So there is some carry concept also there. like 38, so 3 is getting carried and 8 we are writing. So like it was that kind of question.
Yeah, you post that question in the WhatsApp group, sir. I will
Okay,
check.
sir. Yes, sir.
Right. So next for the these are the common operations I applied for single linked list. And for double linked list, I won't cover all the operations. I will concentrate on insert operation, and I will concentrate on delete operation, and then traversing in the sense display. So even maybe few more things I will add, but for circular single linked list and for a circular double linked list, for these two I will cover only these three operations, like how to insert the element, how to delete the element, how to display. That's all. So for double linked list I may add a few more, but for circular these are the operations that I'm going to cover, because whatever concept you are learning in these 2 days, try to practice in these 3 days. Anyway, Friday, Saturday, Sunday, we don't have any class. Practice. You can solve any kind of question with this knowledge. Okay. So Monday and Tuesday, we are going to concentrate on this linked list, so that maximum Tuesday, we are going to wind up this linked list concept. Okay. Then, sir, these stacks and queues I am planning for a separate session. Okay. And hash table I will start. Hash table, hashing, these things will come here, and then we will continue in the next week. Sir, maybe for stack and queue, I'm going to take extra class. Probably not this weekend. Next weekend it may have. Okay. I will inform you the timings. One day full 2 hours like that we will spend on stack, and 2 hours we will spend on queue. Okay. So Saturday stack, Sunday queue, like that we will discuss. Okay. Right.
Yes, sir. I have posted the test case like it was like that.
2 plus 5, 7. Okay. 4 plus 6, 10. We are going to get only 0. And 3 plus 4, it is 7. The previous value you have added here, right?
Yes, sir.
And what is this one?
Sir, this is explanation.
3 plus 4. You are adding from the ending. It is something like binary 5 plus 2, 7. 6 plus 4, 0. Okay, we will see, sir, this one. Okay. I will check it.
Yes, sir.
Right. Okay, sir. Remaining things we will continue on Monday, sir. Please practice the programs up to this. I will upload these running notes within a few minutes, and I will give that a PDF also. Please look into that. Okay. Right. Thank you.
Thank you, sir.